Okay, so today we're going to be talking about similar polygons. Guys, we did a lot of work on congruent shapes. Now we're going to be talking about similar shapes. That's a whole different thing. That's going to be something that you should be very familiar with, though, because you see similar polygons all the time. Guys, when you see a picture of somebody, that picture is not the actual size of the person 99% of the time. So most of the time when you see a picture, it's going to be smaller than the actual whatever they're taking a picture of. That means that it's scaled down to a smaller size. It is the same shape, but it is a different size. So that's the whole idea behind similar polygons. Let's go ahead and give you some formal definition to go with this to start off with. Similar polygons are going to be polygons with corresponding angles congruent. Okay, that's the first part of it. All of the corresponding angles must be congruent to each other. Corresponding angles must be congruent. If they're not, then it's not going to be similar. But they also have to have, so I'm going to write and, I'm going to put this hopefully so you can see it. It means it's a big deal. And, capital letters, double underline. Guys, it has to be, both these things have to be true. And the corresponding sides are proportional. Guys, see why we're doing this right now? Because we just did proportions. And these have to be proportional to each other. The sides must be proportional. So we're going to look at these two shapes. These two shapes are quadrilaterals. There's no special type of quadrilateral. It's just a quadrilateral. And we're going to start by going through and talking about the congruent angles. So when we look at this, you need to be able to identify, because it's one of the things we got to do on here, the congruent angles on the similar polygons. In this case, angle A would be congruent to angle H because they both have one mark. Angle H. Angle B would be congruent to what angle? E, good. And then C would go with what one? F. And then, which one haven't I done yet? Angle D would go with what angle? G. There you go. So you're going to have to be able to identify the congruent corresponding angles. Those angles are congruent to each other. They're in the same spot in that shape. They are corresponding congruent angles. The other part of it is a little bit different, guys. We don't have congruent sides. What we have is proportional sides. Let's show you what we mean by that. You're going to write what's called an extended proportion. Because there are 4 sides, there are going to be 4 ratios. If there were 3 sides, there would only be 3 ratios. If there were 6 sides, there would be 6 ratios. However many sides, that's how many ratios you have. You're going to put the numbers from the one on the left, unless they tell you otherwise, guys. You always go left to right, just like any other math problem you do on Earth. So we're going to go from 3 to 1.5. So 3 on top, 1.5 on the bottom. Then I'm going to go from the 2 to the 1. What does the 2.5 go to? The 1.25. So 2.5 on top, 1.25 on the bottom, and then the 4 goes with the 2. Now, are those exactly the same numbers on all? Are those the exact same numbers on all of those? No, but grab your calculators. What's 3 divided by 1.5? 2. What's 2 divided by 1? 2. What's 2.5 divided by 1.25? 2. And 4 divided by 2? 2. So, do you see they're all proportional to each other? That means that the same number is multiplied times all the sides. Guys, basically this size is twice as big as this one. To go from these, you're going to have a fraction that is going to actually reduce out to 2. It's twice as big. This is going to be a number that we're going to use. It's called scale factor. We'll get to finding it in a minute. Just so you know, that's what it really is. This is really your scale factor 2, because you would have to multiply each one of the smaller sides by 2 to get to the bigger one. Okay, here we go. So when you look at this, Two polygons are similar if and only if. What are the two things that have to be true? The sides, wait, can't say just sides, the corresponding sides what do they have to be? Are proportional. Nope, still didn't get that right. We'll start again. I skipped a syllable of it. Proportional. There we go. We'll get it right. So, corresponding sides are proportional. And what's the other thing? Corresponding angles are what? There you go. Corresponding angles are congruent. That's the only way you can have similar items, guys. Similar polygons. Those two things must be true. If they are not true, then you do not have similar polygons. Because the first thing you have to do is tell me, are these shapes similar or are they not? Okay. Anybody still writing? I don't want to get ahead of anybody. Okay. Guys, let me know if you're still writing. I will definitely stop. Okay, guys, so on the next one, when we deal with this next one, you're going to be dealing with the same exact picture. Guys, this is the same one. We already said that all the sides were proportional and all the angles are the same. So we can say that these shapes are similar. This is the little symbol for similar. Okay. This is called a tilde, T-I-L-D-E. T-I-L-D-E. And that means this shape is going to be similar to this one. Now, the order of the vertices matters. You cannot change the order up. So, because A matches up with H, it comes first, and this one comes first. Because D has 2 marks, and G has 2 marks, and this one's last over here, then this one's got to be last over here. So if I change the name around, and let's see what I named it. If I call it, to begin with, let's see. If I call it CBAD, 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 CBA, and then around to D. Then what would it have to be for the other one? F-E-H-G. No problem catching up with that similarity and that correspondence. Awesome. No issues there. Anybody see anything about just the naming it? You got to stay in the same order. It's got to be connected the same way. You can name it different ways, but it's got to stay in whatever order you name the first one. You got to name the second one in that same order. Okay, guys. So from here, the next thing. Let's see. Oh, are these figures similar? We got 2 problems like this. I think one's on the front. Are we one on the front, one on the back?
Could you go back like really right quick?
Yeah, absolutely. Tell me anytime. Guys, is one of the similar ones on the front, one on the back? I think it is. Okay. I just couldn't remember how it was split up. Okay. Just let me know when you're ready for me to go to the next one.
Yeah, I'm ready.
Okay, good. Yeah, guys, anytime, please tell me and I'll go back. Okay? So, are these figures similar? The first thing you got to know, until you know the angles, you can't decide if they're similar. So the first thing we got to do is use the information in this problem to find the other 2 angles. Guys, what kind of triangle has 2 sides the same? What's the word again? Isosceles. So an isosceles triangle has 2 sides the same, which makes the 2 base angles the same. So we start off with 180. We subtract the 40. That's going to leave us 140. What do we do with that 140 because it's an isosceles triangle? Divide that by 2. So each one of these is going to be 70. We'll do the same thing on the other triangle. 180 minus that 50 is going to leave me 130. Again, base angles are going to be congruent, so let's divide by 2, and each one of those is going to be what? 65. Now, before I do anything else, are those triangles similar?
No.
You can say no. Now, if it's a no, you have to give me a reason. If it's a yes, your work will be the reason. Let me say that again. If it's no, you got to write out a reason. If it's yes, you showing me your work is your reason. So, it's no. Why is it no? Because what? What kind of angles are those called? Corresponding angles. are not congruent. Corresponding angles are not congruent. Good. Okay, that should be everything on the front side of your page. Let's go ahead and flip it over to the back when you're done, and we'll go through and work on the next one. So for this next problem, you're going to be dealing with, are these figures similar? All right, done with this one. Anybody still working? Okay. So, are these figures similar? So, to do that, you're going to take the two that are here, you're going to add them up, subtract from 180, so 80 plus 60, 140, and 180 minus 140. That's going to leave you 40. There we go. Here's that one. The next, oh guys, you shouldn't have to do the math on the next one. Look, 80 and 40, 80 and 40. If it's 80 and 40 and 80 and 40, then this one right here has got to be 60, so this one's got to be 60. Shouldn't even have to do the math for that second one. So, do you see all corresponding angles are congruent? We just proved that. We did the work for it. This is our work for it. We got it labeled. We're good. Then we need to look at the sides and see if they're proportional. Guys, start from the left, go to the right, unless they tell you otherwise. So the 5.2 is going to go over the 3.9. The 7 is going to go over the 5.25. And then the last one, the 8 is going to go over the 6. Okay, this is going to be calculator work, so grab your calculators, guys. 5.2 divided by 3.9. 1.3?
1.3.
Oh, it would be different, guys, so be careful. Is it 3 forever?
Yeah.
Okay, does it show on your doesn't it do like on your calculator though, it's like 1.3333 and then there's a 4 on the last one? No, not on this one. That's on the 1.666. It rounds it on the last one. Puts it at 7. This would just stay 1.333 forever. Okay, now do 7 divided by 5.25.
1.3.
It's the same thing?
Yeah.
Are all three the same?
Yes.
Okay. So if all three sides are proportional and all three angles are going to be the same, then are these figures similar?
Yes.
And that would be your work. You've shown that the sides are proportional and the angles are the same, so that's it. You're done. You don't give a reason for that. Okay, so we have one last type of problem dealing with scale factor. Does anybody have anything before we do that? Okay, here's our last thing then, guys. Okay, so these are, do you see the exact same shapes? I just took the same ones and used them. So we're going to be finding scale factor. This is like looking at a map and you see at the bottom it says like 1 inch equals 5 miles. This is going to be a number that you're going to multiply by to get from one shape to the other. The order that you go in is determined by the question. If they don't tell you, it's always from left to right. If they tell you, you got to go with the order they say. This says go from ABC to XZY. So I'm going from this one to this one for the first one. So guys, look at those numbers. Which pair is the easiest pair to deal with? 8 and 6, because there's no decimals. No decimals in your fraction. Don't do harder things than you need to. So it's going to be 8 over 6, and then you just reduce it down. What's 8 over 6 reduced to? 4 thirds. 4 over 3, however you want to say it, 4 thirds. For the next one, you're going to be going from XZY to ABC, from here to here. Because of that, what would go on top? 6. So it'd be 6 over 8, and 6 over 8 reduces to 3/4. Now, let's talk about these numbers. Guys, if the number is an improper fraction or a whole number, anything like that, you're going to be making the shape what? Bigger. Okay? If the number is less than 1, then you're going to be making the number smaller, making that shape smaller. So again, we'll talk more about that later, but that's a concept that we use later on, so I want to make sure you see that. We see that in another chapter a lot, so that's a big thing. Okay, then let's use scale factor right here. We want to look at scale factor for this shape. We're going to use the scale factor from this problem to do the next part of the problem. This would normally be on one thing. It just was separated in two to talk about the two separate concepts. We're going from the first one to the second one. From the A, B, C, D, E to the R, S, T, U, V. Okay? What's the only two sides that have just numbers on them? No variables. Okay, so the 6 and the 4, the AB and the RS. So my scale factor is just going to be 6 over 4, which reduces to 3 over 2. No mixed numbers, because we got to use it as a proportion, in a proportion in a second. So 3 over 2. Okay, everybody okay with the scale factor? Okay, then we're going to use that scale. This is the same problem. I just put it on the other side. This is the same exact problem, but we're going to use it to find x and y now. So we're going to use that scale factor, which is 3 over 2, and set it equal to, well, let's figure out what we'd set it equal to for x. If we went from here to here and did 3 over 2, then we got to go from here to here and put it as x over 3. And then how do you solve any proportion? Thank you. Cross multiply. It's going to be 3 times 3, which is 9. 2 times x, which is going to be 2x. Divide by 2, and 4.5 equals x. Make sure you can see your decimal, guys. Alright. The last one, guys, what are we still using in this problem? We're still using that scale factor of 3 over 2. A couple of y'all said 3 over 2, some of y'all said scale factor. That is correct. We're still using the 3 over 2. But then we got to find the y, so then we're going to use 8 over y plus 1. 8 over y plus 1. Okay, cross multiply that. That's going to be, guys, you got to multiply the 3 times both these. So it's going to be 3y plus 3 equals 16. Minus 3 minus 3. 3y equals, ooh, this is not going to divide, is it? Divide by 3, and y equals, yeah, you got to leave it that way, guys. If you divide that, it's going to be repeating. I'm trying to think, is it 4 1/3, which is 4.3 repeating? Yeah, we can't have a decimal that repeats, and we don't, guys, don't do mixed numbers on this stuff because we use it in proportion, so we don't want that. Just leave it as 13 over 3. Okay, guys, that's your notes for today. Let's go ahead and get you working on your worksheet.